Okay, gonna do this quick because line charts are not that difficult of a concept to grasp. What line charts do, what they are really, really good at, is showing change over time. And that means your x axis is going to be decided for you before you even start. If your chart is talking about how things change over a season, how a team played at the beginning of the season versus the end of the season, how a player progressed over many seasons, anything like that, your x-axis value is almost always going to be a date. So you have to have date data. So let's look at how Nebraska ran the ball last season. I tried this with this season. There aren't enough games yet to make this look really good. So I've imported last season's football log, so I have every game. And you'll see down here, I have a date value. Or if I want to look over here, the second column is date, and it is of a type date. And you can even look at that here, where here you go. So this first game in here was played on September the 3rd, 2022. This date, for this to work correctly, has to be of a type date. Now, fortunately for us, the data that we've been working with, the sports reference data, it is of a type date, and you'll be able to tell its type like this. This date, lowercase d, means it is a date type object, so we're good. All right, so let's create a new data frame, and let's get Nebraska. So I'm going to do NU, and I will do football, pipe, filter, team equals Nebraska. And just like that, I've got the 12 games that Nebraska played over here. Just like that, I'm pretty much ready to go straight into ggplot. This is one chart type where you're not going to be doing a ton of stuff to it beforehand because you're changing, you want change over time. So you want those individual dates. You want the individual records. You're not doing any group by or summarize here. So geom line is the new geom line. So data equals NU. My aesthetic, remember the X is already spoken for. It has to be the date. So it's date already. The Y is the number that you're charting. So we're going to look at rushing. Let's look at rushing average. And if I run that, well, here's what I get. Let me minimize that. I get this. Now, one thing to notice right away is that my x-axis, or I'm sorry, my y-axis over here is not 0. I don't see 0 on the ground there. If 2, 3, 4, 5, 6 is here, 1 should be down here, and 0 should be even further. ggplot, for whatever reason, truncates axes on these, specifically the y-axis. That's bad. That creates a spikier version of the chart. It looks different than what it really is, and I'll show you. This is going to be one of the few times we're going to work with something called scale. So this is going to be scale y continuous, and the thing that I want is limits. Limits equals, and this is a C. We have to create a range here. So I want it to be 0, and then my top value here is about 6. So let's make that 6.5. Those are the limits that I want. And when I run this, notice how Nebraska's rushing average decline here over the course of the season gets a little flatter. If you didn't see that, here it is without. Notice that the curves look much steeper, and it looks like we're zeroing out over here. Well, if I undo that and I run it again, it gets a little flatter, and we're actually not at 0. Now, admittedly, in the last game of the season, we ran for less than 2 yards a carry. Ouch. Also, Mark Whipple. That's not good. But, okay, so we've made a chart. We've got a line chart here. The problem is, for this class, a one-line line chart is not a chart. It's not. So if you're trying to turn this in for a project, you and me are going to have words. Well, let's add some things to the list. Let's add some context. How did Nebraska fare compared to the rest of the Big Ten? Well, to do that, I'm going to go back and add the Big Ten here. Filter conference equals Big Ten conference. And now I have all Big Ten football games. All right, this is an important lesson to learn when we're talking about layering. The layers are made in the order that they appear here. So the first geom gets put down first. The next geom gets put on top of that geom. So if I have all Big Ten games, I want that as the first one. I want to lay that down first. So I'm going to do geom line data equals big. AES X is the date. Y is the rushing average. And then I need a plus here. Now, here's one thing I'm going to do. I'm going to run this, and I get art. I get real serious weirdness going on here. The problem that we have in a line that contains multiple teams is that we have not told ggplot how do we separate the lines? How do we make one line into another? Well, the way to do that is called group. And it's very similar to group by. It is not group by, it is group. But we have to group each line by the team. And when I run that, now I get what we call the hairball. This hairball, though, it has a problem. Where did Nebraska go? They flat out disappeared, didn't they? They're not in there. All right, now we have to start working with colors in our layers here. So we're going to make this color equals gray. I'm going to fade the big one into the background, and I'm going to make Nebraska color equals red. All right. If I do that, now Nebraska pops out a little bit. But notice I've got lines that are broken here. I've got things that have disappeared. Well, normally you'd get a little error at the top here that said your scale Y continuous has truncated some things. There are teams that ran for better than 6.5 yards per carry. There's missing, is it getting spit out in the console? That's a new thing that ggplot's doing that I don't like. It's not even telling you that you're truncating things. Well, there are teams that ran for better than 6.5 yards per carry. So we need to make this 8. That got them all. And now we have lines that connect everything. All right, so Nebraska now stands out, but is the hairball really telling us anything? Not particularly. This still is not a great chart. It does show Nebraska over the course of the season just ran less and less and less and less. You basically have Scott Frost getting fired here. Mark Whipple takes over. Anthony Grant gets injured. Quarterbacks start getting injured, and things get rough real fast. Well, no surprise, the best rushing team in the conference last year was Michigan. So let's create a Michigan data frame, and it's the same thing as this, except we're going to make this Michigan. We'll run that. Notice we get over here. Michigan played 2 more games than we did because they went to the national title game. And we can pretty much just copy this here, drop it in here. We'll add MI, and instead of making this red, we'll make it dark blue. And it gives you some idea of how much better Michigan was at rushing the football than we are. There's one other thing you can add that's not a huge deal that we're going to do now, but if you really want to make these stand out, you can add another thing called line width. And we'll make that 1.5. And that will make these a little fatter so they stand out just a little bit more. And there, now we have a story. Now we're having something that's telling us a little bit about what's going on here. That Nebraska did not run the ball very well last year, and Michigan ran it much better week in, week out. And, you know, Michigan went to the national title game and Nebraska didn't. So, this is line charts. It's geom line. Your X is pretty much spoken for. It's going to be a date. It's almost always going to be a date, or I would say a date-like thing. So if you have a season or a game number where it's putting things in some sort of sequential order, some sort of chronology, that's most often going to be a date, but not always, but more often than not. You only really have two things here. You have the X and the Y. In geoms that have more than one team or more than one player or something like that, you have to use group. And then it's a matter of layering and coloring to get to this. All right? Holler if you have questions.